The diagram shows the curve with equation y equals x multiplied by x minus 2 to the power of 2. The minimum point on the curve has coordinates a0, and the x-coordinate of the maximum point is b, where a and b are constants. State the value of a. As can be seen from the graph, the point A is the x-intercept of the graph. To solve for the x-intercept of any curve, we must make the y equals to 0. So we must solve the equation 0 equals x multiplied by x minus 2 multiplied by x minus 2. From the factorized format, we know that the solutions are x equals 0 and x equals 2. X equals 0 corresponds to the point where the curve passes through the origin. Therefore, the a must be equal to 2. B. Calculate the value of b. According to the question, b is the x-coordinate of the maximum point. And at the maximum point, we know that dy over dx is equal to 0. And that is the condition that we will use to solve for b. First, we would need to find dy over dx. Since the y in question is the product of x and x minus 2 squared, we can use the product rule to differentiate this by letting u equals x and v equals x minus 2 to the power of 2. To find du over dx, we differentiate u with respect to x, which gives 1. And to find dv over dx, we differentiate v with respect to x, which equals 2x minus 4. Some of you may find it easier if you expand the brackets first, then differentiate it, or you can also use the chain rule to differentiate x minus 2 to the power of 2 directly. So using the product rule, we will have dy over dx equals v times du over dx plus u times dv over dx. This gives dy over dx equals 3x squared minus 8x plus 4. We know that dy over dx equals 0 at x equals b. This means that 0 equals x substituted with b. And we can use this to solve for the x-coordinate of b. After solving by factorization, we get b equals 2 over 3 or b equals 2. When we solve for dy over dx equals 0, we were solving for the stationary point of the graph. Therefore, it makes sense that we will get 2 points because a is also a stationary point. So the 2 corresponds to a, which we calculated from part A. Therefore, the other answer is equal to our b. And therefore b is equal to 2 over 3. C. Find the area of the shaded region. From part A and part B, we already know that b is equal to 3 over 2 and a is equal to 2. The shaded region goes all the way from 0 to 2, and therefore the area of the shaded region would be the integration of the curve from 0 to 2. It's difficult to integrate this expression as it is right now, so to make it easier for yourself, you can expand the brackets and multiply the x in. After expanding out the brackets, you can see that every term you can integrate by using the standard method of adding 1 to the power and dividing it by that number. D. The gradient dy over dx of the curve has a minimum value m. Calculate the value of m. Since m is the minimum value of the gradient, the question wants us to find the smallest value of the gradient. From part B, we already know that dy over dx equals 3x squared minus 8x plus 4. If we let gx equals 3x squared minus 8x plus 4 and let it represent the function of the gradient, we need to find the smallest value of this function. And the smallest value of this function should happen at the minimum value when the gradient is equal to 0. So we need to find when the gradient of the gradient function is equal to 0 or when g dash x equals 0. So we need to find g dash x for the gradient of the gradient function, which equals 6x minus 8, and set that equal to 0 and solve for x. Once we get a value for x, this is not the value of the gradient, but this is the x-coordinate corresponding to the minimum value of the gradient. Knowing that the minimum value of the gradient happens at x equals 4 over 3, to find the minimum value of the gradient, we just need to substitute 4 over 3 into our function for the gradient, which is 3x squared minus 8x plus 4. And we get the gradient is equal to minus 4 over 3 for this x-coordinate, so m equals minus 4 over 3. Another way to find the minimum value m is to notice that the function that represents the gradient, dy over dx, or gx in this case, equals 3x squared minus 8x plus 4, which is a quadratic. And whenever it's a quadratic, we can complete the square to find the minimum value. After completing the square for the quadratic, we will have minus 4 over 3 at the back, or as the constant term at the back, and therefore that is the minimum value of the quadratic corresponding to the minimum value of the gradient m.